like to extend a warm welcome to everyone for today's Minds, Technology and Society seminar that's sponsored by the Glushko and Samuelson Fund. And all of our speakers have been completely terrific this semester. And today's speaker is Professor Jenna Bednar, who is a longtime friend and colleague of myself. Just to let you know just a few of her appointments, Jenna is Professor of Political Science at the University of Michigan. She's also E.D.N. Goldenberg Endowed Director of the Michigan in Washington program, and she's a member external faculty on the Santa Fe Institute. And so the title of Jenna's seminar is When Order Affects Performance, Culture, Behavior, Spillovers, and Institutional Path Dependence. And so let's give Jenna a welcome.
Thank you, Peter, and thank you so much for turning out. How many of you, so I have a sense, are political scientists or who've had some decision science in your background? About a third. Okay, all right, good. So I'm gonna do a little bit, a broader talk than the paper title that Peter just described. And because what I want to do is take advantage of this opportunity to be with a set of people like you all, cognitive scientists and some social scientists, to describe a fuller research project. The paper that Peter, the title in the paper I circulated, is just the most recent in maybe 9 paper sequence. So this is a project that I'm working on with Scott Page, who's at the top there, who is a mathematical social scientist at the University of Michigan. He's also my husband. Then Yen Chen and Tracy Liu, who are experimental economists. Yen is at Michigan. Tracy was Yen's and Scotty's student, who is now at Tsinghua. And then Andrea Jones-Roy, who is a student of mine at Michigan and is an incredible person, independently brilliant, doing various things right now. So the work that I'm going to describe today covers a set of papers written with these people at different times. But the big question of this work, is if we think about a set of laws, and I'll define a law in a second, does it matter how we roll those laws out in society? So first, starting from the basics, what is a law? I'm gonna use that word a little bit loosely. The social scientists in the room are gonna recognize the term institution. An institution being like a game form, being a set of incentives and information. And that structures a choice that an agent, an individual, has to make. So it's designed to shape behavior, very often in an interdependent environment. So that's when we think about it as a game. You're playing where the consequence of your action very often, although not always, depends on what somebody else does. So that's going to be true in most of the games that I talk about today. So a law, something that we write as a society or a government puts in place because it's trying to change what we do. It's trying to shape our behavior. But the way I'm going to be talking about it today is maybe even broader than that, because we can talk about rules or laws that come about socially as well. Okay, so the kinds of institutions that I'm talking about today aren't always recorded in law, and I still think that they matter. So one of the questions that we have is, if there are a set of laws that a society faces, which is true for all of us, there's lots of ways that our behavior is regulated, does it matter what order those appear in terms of shaping that law's performance? And that is meaning in terms of affecting the way that law changes our behavior. So yes is going to be the answer. Otherwise, this would be a short talk. So some of the games that we're going to look at, the prisoner's dilemma is, if you've studied any game theory, you've seen this. If you studied any more game theory, you've seen this ad nauseum. And the reason that you have seen this ad nauseum is because it actually describes an awful lot of interactions that we have. So in the prisoner's dilemma, and I actually should just invite Emily to come up and give this, because she could probably describe this better than I can. But in the prisoner's dilemma, we have two agents. So for those of you who, I'm not even going to ask this, but if you haven't seen these interactions set up as a game form, I'm going to walk you through it right now, just in case you haven't, okay? This probably for a lot of people might feel repetitive, but just be mindful that that might not be true for everybody. Okay, so what this is a 2x2 matrix where we have a row player and a column player. The row player has to make a choice. In this prisoner's dilemma, we call it cooperate or defect. Okay, so they have a choice of two actions. The column player has the same set of actions, cooperate or defect. I didn't label these axes, but I could have, so cooperate, defect, cooperate, defect. And what they get from their action is dependent on what the other agent does. So for example, and here by convention, in this set of payoffs, the row player's payoff is listed first, column is second. So here the way you would read this is if the row player cooperates and the column player cooperates, they each get 7. Okay. Here, if the row player cooperates and the column player defects, row gets 2, column gets 10. Now, for those of you smarty pants in the room who study the prisoner's dilemma and might be thinking about the payoffs as being reversed here, higher number is good, okay? The traditional story goes it would be a prison sentence, but here, think in terms, higher numbers are good, so that's their utility. All right, so, just to make sure you're playing along, if I am the row player and I'm thinking about what to do, should I cooperate or should I defect, how would I go about thinking about that? Like, what would I like to get? More is exactly right, okay? That's like, basically you get that down and you understand most of economics, right? More is better. So, smarty pants Emily, all right? I could maybe get 10, I could get 4, 2, or 7. What do I want? More. So how do I get 10? Can I pick 10? I can't just pick 10 because my choices are cooperate or defect, right? And if I defect, that's how I could get 10, but I could also end up with 4, right? Which isn't as good, all right? If I cooperate, I could get 7, but I could also get 2, right? So this is complicated. And the reason why it's complicated is I have to worry very much about what the other person is doing. Okay? So in fact, what I'm trying to do is maximize my payoff given what the other person does. Right? So if I think this through, well, gee, if I defect and the other player cooperates, I get the 10 that I wanted. Right? If they defect, I get 4, which is better than 2, right? So my best option here is to defect. And the other person, this is a symmetric game, the other person is thinking the same way. In the prisoner's dilemma, we end up both defecting, which is worse than if we both cooperated. All right, I swear I am not going to do that for all 4 games or any other game going forward, but what I wanted you to see was how it can be representing this kind of choice, this information, which is very constrained information available to these agents, right? The incentives in this particular institution are very simple, but they're interdependent. Okay, so I have to be thinking about how the other person is going to respond. I can't just choose. So anyway, in the prisoner's dilemma, you get defect as, at least in a one-shot circumstance, what is going to happen. You're not going to get this nice cooperation that they could get unless it's repeated. Now, what I've highlighted here is repeated play equilibrium. That is, if over time they each try cooperating and they find that they can get to cooperation. Okay, so that's what happens in the prisoner's dilemma. These other games, 3 games, are just variations on that. Okay, in each of these, it's again 2 players, 2 choices, and they're interdependent. Interdependent, I say that, and then right away, with self-interest, I can actually completely ignore what the other person is doing. If you're interested, you can stare at it and figure that out why, but I can go ahead and defect, the other one defect, and it doesn't, so my payoff is not, what I do is not as dependent on the other. I have a dominant strategy. The interesting games here are strong and weak alternation. Here, we do have a nice cooperative equilibrium, similar to the prisoner's dilemma, but we have another more complex form of cooperation where I win and then you win. I win and then you win, okay? Where over time, we bounce back and forth here, okay? See how these are working? Okay. So we have, as political scientists, taken games like this and used them to describe some very complex problems in political economy, including development, right? So we take these simple games and we use them to help us understand some very difficult puzzles, like why some economies take off and others don't. Because we have this sense within positive political theory, which is what I do, that institutions, that is these rules, affect performance of whole societies because they shape the behavior that people have. What I'm going to talk about here is a set of this possibility that over time we can add games to a society, and the order that we add them affects how people play. So here in one sequence, we start with the prisoner's dilemma, then we add one of those alternation games, and then we add self-interest. In another sequence, self-interest starts, and then self-interest and then alternation, and then we add PD. So you see it's the same set, but we've actually done experiments on this, and we found that by ordering them differently, you end up with different play by the agents. These are like real live University of Michigan undergrads in the basement. Very realistic circumstances, but that just changing the order of introducing these games, they end up cooperating in the prisoner's dilemma in one circumstance and alternating in the prisoner's dilemma in another circumstance. So let me walk you through that. So going back to this question, does the order matter? Yes, but that turns out to be not a very complete question. So even if we can observe this, that doesn't mean that we have even the beginning of an understanding. So here we might better ask, why does the ordering matter? When will it matter, and by how much? So the theory that Scotty and I have been working on for a while is that these laws are contextually dependent and they are related to one another through the patterns of behavior that emerge as a consequence of the institutions that are in that society. So they're embedded in a context, they're subject to interpretation. That interpretation, that is trying to understand what will happen and what's the consequence of my action, is influenced by other institutions as well as by culture. which should cause you to ask, what does that mean? That's intuitive, but what? Explain more. So going back to the basic question, if you have a law that's supposed to shape your behavior, and one way you can approach this is to say, all right, is my behavior, if I do X as opposed to X prime, is that consistent with the law? So it's just yes or no. Right? And then you might be imagining that there's some judge who's going to say, you crossed the line, this is appropriate or not appropriate. That's what we typically think about institutions. All right, you're driving down the road, you see this sign. How fast do you go?
10 miles over.
10 miles over.
I'm just joking.
All right.
I would never break the law. 8, okay,
8 miles over. You're driving along the road with them. How fast do you go?
About 2 miles less than him.
About 2 miles less than him. Okay. So 80, 85, 90, don't go 100, or if you're in Texas, maybe. So even something like the speed limit is not what we call a Brightline rule, right? That there might be many laws, most laws, allow for multiple acceptable behaviors, which mean that's kind of fun for us as social scientists, because it means that it becomes much more difficult to predict the way that somebody will respond to a law. So if these Brightline rules are rare, why are they rare? This is why, as cognitive scientists, we need to be thinking about the way people process information, right? So first, there's a behavioral choice ambiguity, right? So just what is the real consequence of this law? Do I have all the information that I need to figure out what to do here? Are there multiple acceptable responses? That's that speed limit one. Is there some kind of legal or institutional ambiguity? So are there multiple interpreters of the law? I'll give you an example of that from my other work in just a second. Third, socially derived ambiguity. Am I driving on the road with them, right? Or what are the rest of the cars doing? Or am I behind the guy with the big, the hay truck? And spillover ambiguity, which will be meaningful as a phrase to you in about 8 minutes. What have I learned elsewhere that helps me respond to this rule? Okay, so here we are back with Judge Judy. My son's just recently learned that she's not really a judge. What are they doing on the show? Okay, so there is this big gray area. Maybe this is okay. Then somewhat separate from my work on culture is a lot of work on federalism. And with federalism, I highlight multiple institutions, multiple extrajudicial interpreters of the Constitution. That is, how the Constitution derives meaning is not just from, well, obviously she's never going to make it to the Supreme Court, but through a bunch of other interpreters. Okay.
It's pretty open now.
That's true. Wasn't there someone just appointed who had, yeah. All right, so multiple interpreters. That's the last you're going to see of that today, but I've written a book on this. But you might also look around you, this poor guy, to figure out what it is that you're supposed to be doing. Right? So how fast is everybody else driving? So to know what to do, you can learn from others. Yes. So to know how to have these more complex, this is from this morning. Yes, they really did do this. My favorite though is not these struggles. It's Medvedev, right? Check him out, he's like, suck it. There's no reason for me to cross my arms. And I'm just gonna smile. Okay. So we're gonna be thinking a lot about, to figure it out, you look and you think about what others are doing, and then you also think about how you responded in another circumstance that was similar, right? So you're looking at others around you, and you're also thinking about past experience to figure out what to do. And we call this looking about from past experiences behavioral spillovers. So in one circumstance, one institution creating a behavior that when you're encountering something new, you can draw on this past experience, and that creates a spillover in behavior. Okay, so for example, this morning, Mitch McConnell made me cry. Okay, so what is the big thing that he has to be thinking about right now?
Roy Moore?
Yes, Emily, this is for you. This is that slide for you. It's like, what happened this morning? So this is what happened this morning. Yeah.
How is he going to get the donors the tax cut?
Yes, that is on his mind. Like, is this a complete failure of a whole term, Senate term? So so how does that play out with the man in the middle? Who's the man in the middle?
Roy Moore.
Roy Moore. And, okay, so Roy Moore, how does Mitch McConnell respond to this problem that is Roy Moore? That is, this is a problem space. He's got incentives, he's got information, and he needs to think about what position he takes about Roy Moore's candidacy. So this is a real challenge. How do you think through this? This is a very new circumstance for him. So how does he think through it? Well, he could think about the balance of power in the Senate and the fact that he needs to get this tax bill passed, right? So he could think about that, and from that, think about, gee, what do I need to do to make sure that we keep a Republican-dominant Senate? Another way he could be thinking about this problem that is Roy Moore is he could be thinking about the way everybody's responding to all these dogs, right? Two very different kinds of problem spaces and creating really different options for him. And so what did he do this morning?
Told him to step down.
Said step aside, and this is why I cried. It was a good cry. I believe the women. So, he doesn't have any power. Well, he does actually have some power later. He can't do anything about the candidacy. He can't do anything about the election. He can't do anything about seating more. But they can immediately call a vote to expel him from the Senate on behavioral grounds. But they would have to do that positively, right? They don't want to get into that. So anyway, this was a big deal this morning. So multiple games, if you will, multiple institutions or problem spaces, and how he processes this new one, he could have come at it as a partisan, right? But instead he came at it consistent with the way that society has been thinking about all of these other men. Okay, so law in here, mind you, these, although in each of these cases, in several of these cases, there were laws that were broken, the punishment came well before it ever hit court, right? So this is something that was tried in the court of public opinion, and that was something that he was willing to side with. Okay. Law's meaning, socially derived. And so what we want to think about is how that affects law's efficiency and its dynamics. So its ability to change behavior and the way that law might change over time. So as I said, this is part of a larger project where we're thinking not just about culture and the way it shapes institutional performance, but also how institutions shape culture. So for us, culture is not some primordial myths of the Dark Ages kind of fixed feature of society. It's also not something that changes all the time. So in other work, we spend a lot more time defining and highlighting and exploring what culture is. But for here, I just want you to be thinking about it as something that is respondent to, that is patterns of behavior in society. And those patterns of behavior are very much a product of society solving problems. Okay. So from game to games theory, which is the way we originally, our first paper was called Can Games Theory Explain Culture? That people interact in multiple settings, strategic settings, and their behaviors can spill over. These behavioral spillovers create these patterns of behavior. Those patterns of behavior are culture. The three kinds of results that I'm going to walk through, and if I go for like 20 minutes, we're good? Yeah, okay. I'll first talk about the existence of spillovers, because just thinking about it intuitively is of course not enough. Then we had to show that it actually exists. So I'll show you its existence, or how we have found evidence of its existence. And then I'll spend a good 10 minutes or so on sequencing, and then very quickly I'll talk about diversity. And we use different methods as well to fit the kind of, so experiments, mathematical modeling, and agent-based modeling to fit the kinds of arguments we're trying to make. Okay, so on the spillovers. So here's some results from some experiments that we ran. And here, just to walk you through, so prisoner's dilemma, and here's the payoff maximizing behavior. So what we're interested in is the percentage of the pairs who were playing this game that maximize their payoff, and here it would be both cooperating. In strong alternation, that's that you win, I win, you win game, the percentage of pairs who were alternating. And here in weak alternation, I didn't point it out before, but the reason why it's strong versus weak is the incentives with weak alternation are just barely better than if they both cooperate. Okay? So it's weak because the incentives aren't driving that behavior, they're not pointing to it. All right, so we had a control and 3 treatments. And I just want you for a second to look at the variation. So in each, what I'll tell you is in each of these experiments, our undergrads were playing an identical game. Okay, so they're playing the prisoner's dilemma, identical incentives. In the control, 56% of them cooperated, and that's very consistent with the thousands of other times we've tried to see how undergrads play the prisoner's dilemma. At least among the weirdos, you know, the Western educated, industrialized democracies. So about 55% of the time they tend to cooperate, but in treatment it dropped off, 42%, 41%, and 40%. In the controls for strong alternation, 71% of our pairs alternated, but then it dropped off. In weak alternation, they didn't do great in the controls, and then dropped off and did about the same in treatment. So the question is, why?
I'm sorry, what's treatment?
That's exactly right. What are we doing? What are we doing? So here's the standard experiment, right? Here's our prisoner's dilemma, and we've got 2 agents, and they're playing, and they defect. In our experiments, we have our agents playing 2 games simultaneously. Okay, so in a standard experiment, you know, you probably run these. Agents or undergrads sitting, staring at terminals and you know, with cubicles and things. And they're looking at a screen, and on that screen, there's this choice that they have to make, and then they say what they want to do. The only thing different for ours is there are 2 of these matrices, okay? And then 2 boxes underneath. What do you want to do for this one? What do you want to do for this one? Okay? They're not linked in any way other than being on the screen at the same time. Here's updated for today. Maybe we're doing this you win, I win thing with Putin, and not so much with Angela Merkel. Okay, so the variation in these experiments, these were the treatments. So control is just the game played by itself. In the treatment, it's the game with another game next to it. So if the prisoner's dilemma is played with self-interest sitting next to it, then our subjects were much more likely to defect in the prisoner's dilemma. They're leaving money on the table. Here, it's with this prisoner's dilemma is with strong alternation. Rather than defecting or cooperating, what they're doing in the prisoner's dilemma is they're alternating, which, as far as we can tell, the first time this has been seen in the lab, it's a very strange behavior to do. But there was this spillover from strong alternation over to the prisoner's dilemma, pulling them away from cooperating, but doing this other very sophisticated and strange behavior instead. Okay, so why do we see this? Right? Just because we observe it doesn't mean we have an explanation for it. So there are two competing explanations. It could be cognitive overload, or it could be behavioral spillovers. So cognitive overload, what's that? It's just multitasking. You make mistakes. With behavioral spillovers, the idea is that you might be drawing across. So here's the idea of a behavioral spillover, that we might be seeing these patterns in responses. I was just looking to see if I included my slide that reports out the results. For some reason I left it out. But the going back to here, if it were cognitive overload, what we would expect to see is them doing just random stuff. But instead, what we're seeing is that it depends on what, the alternative to payoff maximizing behavior depends predictably on the other game. Okay? So it's not random, which would be true if it were cognitive overload. Instead, it's a function of the other game. Now this is where weak alternation becomes really interesting. This is a case of cognitive overload because the incentives don't drive you toward a particular behavior, and only when you have weak alternation played with strong alternation do they actually improve. And in some other experiments that we've done, they improve even more than this small improvement here. So it's like having strong incentives next to it points them toward, that's really what I ought to do in this otherwise fairly confusing game.
Does it also go the other way? So, jumping in.
No, I'm just looking to see if, because no it doesn't, but so I'm not doing a full talk on the experiments, so I would be able to show you the data on that. No, it doesn't go the other way. And a big part of, this is one of those processes where times in the refereeing process where the referees were awesome because they were so difficult. This paper is published at Games in Economic Behavior, and we had a couple of really, really good referees who loved the paper, but wanted to push us farther on why are you predicting that strong alternation would affect prisoner's dilemma so much? Why is that the direction? Why shouldn't it go the other way? Which is, we're like, totally right. We were all proud of ourselves. We ended up needing to develop a measure of game difficulty. We have an entropy measure for, based on the control data, for how difficult the games are to solve. And then that caused us to have a new, more refined hypothesis that is the flow will go from less difficult games to more difficult games. Right? So self-interest being a very, very easy game to solve because it's dominant strategy pollutes every other game you play it with. Yeah?
So, but it looks like there's so much worse in strong alternation than weak alternation is.
I know. Yeah. Yeah, and there, it's not like we're saying there is no cognitive overload. So this is not a result that we have a handy explanation for. Just one of those things. They just seem to be, it actually doesn't look as bad as with weak alternation with everything else, right? But it's, we just think this is just such a difficult game to solve. Yeah.
If you're doing strong
Morgan.
yes. If you're doing strong alternation in the presence of weak alternation, couldn't you make the argument that you're providing them evidence that, they may have to look harder at this problem?
Yes.
That it may not?
Yeah, that was our thinking about why behavior, didn't sink quite as much and actually improved here. Yeah, that you're guiding them, you're giving them some sharper insight into how to play weak alternation. That's what we were thinking. But in light of what Paul said, we can't say too much here when you have a really difficult game. But for these moderately difficult games, we're very confident about our prediction in terms of the flows. Okay. So culture, this is work done by my colleague Ron Engelhardt, mapping out, he's got this with 1 million co-authors, thinking about the way that people from all different parts of the world order their values, and then comparing survey results from different countries, we can see cultural clusters emerge. So culture is meaningful, we can observe it, but what we're bringing out here is just thinking that it might affect laws and in a way that we might be able to theorize about. Okay, so key insights from this little Spillovers interlude. So having found experimental evidence of it and then other computational stuff that we did, if you approach law the way that we are trained to do as formal political scientists, where we think we map out as carefully as we can all of our assumptions about incentives and information, we still may miss out on our predictions of behavior. And in the past, at least when I was in grad school, it was always like, well, yeah, culture explains it. What we're trying to do is say, okay, culture explains it is not an explanation. That's just begging the next question of what is it that culture is doing. So what we're trying to model here is develop a theory for how it is that culture and institutions are related. Okay, so now moving into sequencing. If we've established that games played simultaneously are polluting, what happens when you roll games out or laws out sequentially? And this is that paper that I think was circulated. What we want to do here is be really precise about what it is that we're modeling. So when does, political scientists are kind of taken with this phrase, path dependence. But it's often used in kind of a mushy way. So the way we want to use it is, when does a change in that sequence cause a change in the performance or outcome of an individual game? So when we see path dependence. So in this model, which I'm not going to get into the math, but I'll just set it up for you. The games arrive in sequence. In the first game, everybody plays that game as if they were good economists, right? So they play it efficiently. But thereafter, there's a history. So in any other game, there is this, the way that agents initially respond to this incentive structure depends on their type. So we have two types of agents. We have some who continue to be these good economists who are efficient, hyper-rational, right? And then we have others who play the equilibrium strategy of the nearest game. Okay, so they think about it, and they think, what have I done in the past that was similar to this? I'm going to try that first and see how that goes. And thereafter, I'm going to do what we call best response dynamics. That is, I'll think about how well I did, I'll think about how well everybody else did, I'll adopt the behavior that was most successful. Okay? So these aren't idiots, they're groping their way toward trying to maximize their payoff. Okay? So we have two types, yeah.
I was just wondering, some of the scaling of the numbers for the payoffs in the boxes
Yeah.
made me think of, it seemed like the way I would interpret it is like almost like a win-win, because you've got like, I either win some or I win some more.
Right.
Depending on what way you want to look at it.
Yeah.
And so I'm just wondering how much the idea of simply laziness and knowing that you're going to win, because most of these models are constructed
Yeah.
like win-lose, and then you've got these competing partners because the incentives aren't fully aligned.
Right.
And I'm just wondering how you think that plays in, if that scaling makes any difference.
You know, that's a really, really interesting question about research design. So first, when we do our computational agents, we can force them to always try to get more, right? But the real question is, can you force University of Michigan undergrads to always want more? You know, or maybe enough is enough, right? We can't do anything about that. So you try to set up the incentives in a way to motivate them. You try to hope that they do care about, you know, they have the possibility in those experiments. Typical take home was between 20 and 40 bucks. And I hope that 40 seems like more than 20 to them, but it's true. This is absolutely a problem for all behavioral research. Is, you know, do people have a real motivation to respond? That's a really good question. Okay. So here, and actually in this is all mathematical, so we're not even dealing with computational agents, we're just solving for equilibrium. So we have this parameter here, this is a gamma, of the proportion of the population that's going to draw on experience, okay? So we think of this as the cultural sway, that is, they're drawing on their behavioral spillover. Okay, so questions we asked, is there such thing as institutional path dependence? Do these behavioral spillovers influence? Does it necessarily imply inefficiency? And finally, can we think about optimal sequencing of institutions? So I'm going to show you a couple of games, and I'm going to skip over some middle parts. But if it feels like I go too fast, just let me know and we'll go back into any of this, okay? So here's a game. It looks a little bit different from those other ones. This is where you're just trying to match the behavior of the other player, okay? But the question is, you know, here we gave it some labels. Be conservative or traditional or innovate, right? And all you want to do is match what the other person is doing. So there is some positive payoff in these off diagonals if you miss, but your payoff is maximized if you hit. Okay, now you'll notice in here there's a parameter, a theta, and so whether you prefer to coordinate by being traditional or coordinate being innovative is dependent, of course, on what this theta is. Okay, and we're going to let this population gamma, 75% of the players are going to draw on past experience. Okay, so here, as long as theta is less than 8, then what you want to do is play traditional. If theta is greater than 8, ideally you'd play the game, you'd innovate. Okay. And here, different game forms then are different thetas. Okay, so you can see as theta moves, that's going to change the whole game slightly. So when we talk about different games, we're just talking about different thetas. All right, so let's talk about a game form where theta is set to 9. This is what it would look like. And so ideally, where would you coordinate your behavior? You'd innovate, right? Okay. So if that's our first thing, theta set at 9, you would innovate. Now let's introduce another game and set theta equal to 7. question is, what should you do?
Depends on who you're facing.
Exactly. Why? I feel like I've taught something, right? Like, let's just pause for a moment and say, yes, Bednar, success. Because you should have said, or like if you were just an economist, a mere economist, you would say, oh, you'd play traditional because I just told you that if theta is less than 8, then tradition is your payoff maximizing behavior. But you said instead, it depends on how fast they're driving, right? It depends. Right. So here, it depends on what that gamma is, the proportion of people who are thinking about what they just did, right? They're going to respond in a particular way because what you really wanted to do is coordinate your behavior with them. If you did this other thing, you're losing. You're leaving money on the table, right? So we call this game a susceptible game because it's susceptible to spillovers. This is a detail of the way the model is struck with different thresholds. I'm going to skip over that. But what I want you to see is there's in this game space, this set of games for any theta, there's a set of games that are susceptible and a set of games that are immune. Meaning that if the theta, if the game payoffs are out on these edges, it's not in danger of having the society misplay it. Only the ones that are in the middle are susceptible to spillovers. So from that we derive this immunity score, being able to think about how susceptible to spillovers a particular game is. And we use this to start thinking about optimal sequencing. Okay? So here we have a sequence. These are 5 different epochs, or times when we roll out a new game. Here we start out with alpha, the first game, a game where the efficient play, here I've switched, and anything to the left of 8, you want to play A, anything to the right of 8, you want to play B. Okay? Start out over here, the society ends up adopting A. Next epoch, we introduce a game over here, society plays B. Then we introduce a game here at 10, theta equals 10, they play B. Here at theta equals 9, they play B. Here, we introduce theta equals 7. They should play A, and instead they play B. So the sequence, by ordering it in this particular way, we get this inefficient play. So that's an inefficient sequence. We could order it differently, same set of games. Here, 4, then 12 is our thetas, then 7, then 10, then 9. Can anyone see what we did differently in this path? So let me go back. Here, 4, 12, 10, 9, 7. Here, 4, 12, 7, 10, 9. Yeah.
Are you narrowing the parameter, so to speak, the range that you expect to find the proper?
What we're doing is we're starting with extremes and we're marching in. Okay? So we start, if we know that this is the set of games that need to be rolled out in society, the way to create efficient responses is to start at the extremes and move in. And that maximizes the likelihood that you end up with efficient play in each of those games. Okay, so what set of results that came out of claims in the paper, first institutional path dependence, very common. It was actually quite hard to rig it, so there wasn't some kind of path dependence. And it depends on that gamma, on how big the magnitude of behavioral spillovers are. Less intuitive results, so first you want to, it's terrible if you have a model and then you aren't able to confirm the things that seem intuitive, right? So phew is what we said when this happened. Less intuitive, so here's where we get more excited. Path dependence is necessary for efficiency, so this is related to a setup that I didn't show you, but if instead, so one alternative to path dependence, remember that means that the sequence affects play all the way through. One alternative to that is extreme sensitivity to initial conditions. That is, play is entirely determined from the very first game. There's no path dependence there because the path doesn't matter other than the very first thing. So path dependence is actually necessary. This early diversity, playing the outsides and moving in, leads to greater efficiency, so that's the big optimal sequencing result. We also address something, this is getting into the weeds of political science, although it's a very important theory in political science about endogenous change to institutions, Greif and Layton's paper, and some concept of quasi-parameters. I say all this knowing that 85% of you are really bored right now, but you people might want to go look this up. And then another interesting thing that I didn't highlight has to do with how the consequences of how strong your punishment is in terms of being able to play games efficiently going forward. Okay, so that's all in the paper. Last thing, which is quite quick, is diversity, and then I want to open it up to some questions. So again, continuing this sense of sequencing, we're really interested in the kinds of game forms or laws that might help populations. So here's where we're going. We're not quite there yet, but where we're going is we want to think about the way that laws might encourage population resilience, meaning how well populations are able to weather downturns or robustness, to draw on the ways that I think about it. So can societies recover from, say, a crazy election or something like that, right? Will democracy survive? To be able to address questions like that, where you want to be thinking about the kinds of behaviors that institutions support. And this is a paper that came out last year in the European Journal of Political Economy. This was published with Andrea Jones-Roy. So we took our games, and just looking over here, we were able to calculate from them the effective number of behaviors that are supported by the game form. So that the game form, so with our, this is all computational stuff, our little computational agents came up, they had different approaches to solving these institutions. How many kind of survived going forward in evolution in each game. So with a hierarchy game, this is a different game from one that I've introduced to you, the effective number of behaviors that are maintained are 2.3. Okay. Prisoner's Dilemma is able to support almost twice as many behaviors. So what difference does that make? Well, we developed a way of showing how paths of games might roll out. And so this is for a set of, how many is this? 7 different games. If we start with 1, starting with X, and then we move, say, to the Prisoner's Dilemma, and then from the Prisoner's Dilemma, we moved, say, to alternation. So that's a path, okay, that could be represented by this sparkler graph. That's the technical term that we apply to this. All right. So the question is, and this is why I find this interesting for resilience. Resilience might require some innovative responses to new circumstances. So how many new kinds of games can you solve optimally? So what we want to do is be able to maintain optimal performance as we move through different games. So what we show here is if it has a connection, then you can continue to play the new game, or you can play the new game efficiently given the sets of behaviors existing in the population from the old game. Okay, so if you start with prisoner's dilemma and then you move into alternation, then you can then play most other games efficiently after alternation, right? So prisoner's dilemma keeps a lot of things alive. This bottom left, which is one of those hierarchy games, you see missing connections. That's because you can't play these two games optimally if you start with bottom left. So what we're getting toward is thinking about diversity, behavioral diversity in a society that's maintained through certain institutions or killed off by other institutions. Okay? So it's still early work. We did publish the one, this paper, but we haven't. What we want to do is move forward now and be thinking about the implications for robustness. Okay? So just to wrap up, the takeaways that I like I said before, I feel like it's already been a success. But I wanted to introduce to you this mechanism of behavioral spillovers as a way of thinking how culture and laws might affect one another. And that legal sequencing we can start to understand by using this concept of behavioral spillovers. And that more specifically with optimal sequencing, it's going to maintain diverse behaviors. This may not be gradual as in reference to the political science work that was advocating gradualism. And then it also includes low punishment for errors, that is, embraces innovation and doesn't punish it. Okay. I love your questions.